Hello, today I'm going to be talking about OICR's genomic department strategy for managing big data in a high throughput genomic pipeline. Let's start with why we need to do this in the first place. At the Ontario Institute for Cancer Research, or OICR, we're a collaborative research institute that conducts and enables high-impact translational cancer research. We work collaboratively to develop new ways to find cancer earlier, treat it more effectively, and ensure it does not return. OICR Genomics is a collaborative initiative between OICR and the University Health Network in Toronto that supports basic, translational, and clinical oncogenomics programs. Within this program, GSI, or Genome Sequencing Informatics, is a team of bioinformaticians and software developers who analyze genomic data produced at the Institute, directly support collaborators and researchers with their bioinformatics analysis, and develop, maintain, and operate the core analysis infrastructure. Last year, GSI handled the processing of over 1,400 terabytes, or 1.4 petabytes of data, and sequenced over 700 terabases. These two charts here show the terabytes of analysis data and the terabases of genes sequenced over the past decade. As you can tell, we've seen an increase in sequencing and analysis over the years, and for GSI, it doesn't stop there. Our data processing demands are only expected to increase in 2024 with the onboarding of two new Illumina NovaSeq X Plus sequencers and migration to larger capacity 25B flow cells. Our solution thus far has been to increase our storage capacity on site. However, exponential growth of computer storage and the resources and money required to maintain that is not a feasible long-term strategy for us or our IT department. To help contextualize how much information 1,400 terabytes really is, putting that 1,400 in terms of a potentially more familiar storage medium, to store this much data, you'd need over 2 million CDs, or if you go back to an older generation of storage, over 1 billion floppy disks. Or going back to an even older storage medium, you need over 105 billion sheets of paper to print all this information out. In addition to the resources required to store such large amounts of data being generally expensive and difficult to manage, GSI and OICR must ensure this data is stored safely and securely while respecting individual privacy and safeguarding all confidential information. As well, for accredited cases where clinical reports are generated, there is a requirement to retain data for 2 years. Not every intermediary file needs to be stored, just the ones necessary to regenerate the results if needed. And if you are interested in hearing more about our clinical reporting, be sure to tune into the BOSC Talks tomorrow morning to hear more about that. And all of this means we have a lot of data, some of which needs to be kept and all of which needs to be handled quickly and securely. This leads into how we've chosen to handle it. We began addressing this via reorganization of how we track information. Assays available through the genomics core consist of a distinct set of samples, now defined as a case, which are analyzed together, producing a variety of deliverable files and reports. For each assay, all data from a set of samples, or case, can be scheduled for deletion once work is complete, and the results and clinical report, if required, are sent to a collaborator. This is a simplified overview of the process we have designed, the majority of which can happen without any human intervention. If you're interested in a little bit upstream of this, Mike will be discussing how we handle quality control, project tracking, turnaround time reporting, and more back here right after the break. But back to automating deletion. To begin, complete cases are identified by a script. Once a case is identified as complete, the quality control metrics are archived using software which allows the user to access QC data without having to access any associated files. As well, the files and analysis metadata, which will need to be kept for a given case, is determined. A list of files which cannot be deleted and thus will be sent offsite is generated. These are then encrypted and backed up to Amazon Glacier, an online cloud storage service. Once the backup is confirmed, the retrieval information is stored locally. This ensures that if files need to be reviewed or resent to the collaborator for any reason, it is straightforward to initiate the archive retrieval and decryption and move the files back into our local space. At the same time, all relevant metadata, including the information about the analysis pipeline used, is moved from our active systems to an archival version of our workflow registry and analysis metadata tracking system. A command is then generated to remove this metadata, and the workflow runs from our active systems. A human confirms we definitely want to remove the workflows and runs this command, although as a note here, this year we do hope to automate this step as well. And then once both these steps are complete, the files are automatically deleted, freeing up space for the next case. To conclude, as we move forward with this system in place, our goal for 2024 is to have net neutral data usage, deleting data throughout the year as each case completes. To do this, we've developed a mostly automated process which allows the team to meet accreditation requirements and ensure data integrity without requiring continually increasing storage. A big thank you to the whole GSI team at OICR, and thank you all for listening. If you have any questions, happy to answer.
Thank you. That was a great talk. You handle such a large amount of where do you store the data? Is that all on premise?
Right now, it's all on premise. Yeah.
Okay. Is that how you're going to keep it in the?
Yeah, so right now we do have a data center on location at OICR, but pretty much every month of last year, we're butting up against filling up that entire quota that we've been allocated. So that is why we are looking to move any files that we need to keep onto Amazon Glacier cloud storage so that we don't have to keep buying more hard drives, buying more compute power ourselves.
Oh, okay. So you kind of have hybrid system now, most of it on premise and then some, the archive.
Yeah, right now, mostly on premise, and all our analysis and processing is done on premise on our high performance compute cluster. Yeah.
Okay, thank you.
Thank you very much. Nice talk. Since all your data storage seems to be on-prem, can you talk about a little bit about your workflow from sequencer to storage? Like, how do you, feels like a big question, but how do you transfer data off of the sequencing instrumentation to wherever you have it?
That's a great question. There was a great talk about it this morning. So
Sorry, I missed it.
No, it's too bad. I would have promoted Beatrice's talk, but yeah, probably our analysis team can answer that question better.
Okay, thanks.
Sorry.
Yeah, no.
Nice presentation. What data you keep? You keep the BAM file, or so for sometimes people come back, so you don't need to rerun. So do you use data object or what? And yeah, more details.
Our plan right now is not to keep the BAM files, but to keep the FASTQ files where necessary, so that we can regenerate the BAM because we have our analysis pipeline saved as well. If we need to reload that data back into our pipeline, we can regenerate everything.
Yeah, but if you keep the FASTQ file, you need to rerun again. But the BAM file, you can keep going, and you can go back to the FASTQ file. So why you keep the FASTQ file?
Generally, just because they're smaller, and our goal is not to have to reload and rerun everything. Ideally, once we have given the collaborator all the information they need, they have that. This is just in case something happens and they need their data back.
Thank you.